Okay guys, we're going to look at a few expressions here that we just want to be able to evaluate. However, what I want to point out is that any of these expressions that I'm giving you here involve angles like say 60 degrees, 30 degrees, or pi, which is the same as 180 degrees. And that is to say that really what I'm looking for you to use here is your unit circle in order to be able to evaluate these. So with respect to your unit circle, let's really quickly review a few key facts, and that is to start with that if we have an angle in standard position, so here's our angle theta, and a point on the terminal side xy, then we have this right triangle situation right here where we know this is x, this is y, and what we've referred to up and now is r. Now when we look at specifically the unit circle here, the difference is going to be that our r value specifically is equal to 1. So I'm going to try this one more time here. But essentially when we look at say some angle in standard position this time, and this would be my angle theta, perhaps what we consider is that I still have a point on the terminal side and I can still make this right triangle that is x by y by r, but specifically we say that the r value is 1. The reason why this is significant is because when we do our definitions of sine and cosine, which are respectively y over r and x over r, what we're truly getting in the unit circle sense is that we really get y over 1, or y and x over 1, or x for sine and cosine respectively. So what this truly means is that if you're a point on the outside of the unit circle, then the x value of your point tells you the cosine value here. And if you're a point on the unit circle also, the y value of the point tells you your sine value. And with respect to tangent, well, the neat thing about tangent is that we can just take y over x, which really just reinforces one of our identities, that really what we're doing is we're taking the sine value over the cosine value. So with respect to your unit circle, we certainly want to know that all the points on the exterior are telling us both the cosine and the sine of the angle that you're sitting at, but also that we could find the tangent by taking the sine over the cosine. Now why is this important? Well, because we need to evaluate these, which means I'm also going to have to be really good at knowing the values of some of these points around the outside of the circle. So we're going to go ahead and list at least these 4 points here because they are at our quadrantal angles, and here's what we know. The radius of the unit circle is 1. And so we would either go right 1 or left 1 from the origin, but we could also go up 1 or down 1 from the origin. Now, in terms of other points that we'll want to illustrate here, the other 3 angles, or the points that we draw in at, are at these angles of 30, 45, and 60. And so when you look at them, I think it's going to be a little bit easier if I have a little bit more room to draw here. We're looking at just the first quadrant here. These 3 points here, in terms of their sines and their cosine values, or I really should say cosine and then sine values respectively, all have something in common, and that is to say that they're all over 2. They're all over 2. So now when you look at the rest of their values, how we know these, I would say that you always just keep in mind that your x values starting at the top left go 1, 2, 3. And then starting in the bottom right, we count back up 1, 2, and 3. So knowing this here, okay, and I would have put these really on this picture right there, just they didn't have a lot of room. We could use these to help us evaluate expressions like those you see up here. And so when I say, hey, you know, really I want you to go find the 8 times the sine of 60 here, what I really mean is we're going to have to go find what is the sine of 60. And so looking at our unit circle, I suppose that at a 60-degree angle here, what is our sine value? Well, our sine value would be the y value there. So root 3 over 2. It means that 8 sine 60 is really the same thing as 8 times root 3 over 2. And you know what, if it helps you to see this here, we can put our 8 over 1 times root 3 over 2, but of course we multiply straight across, and before doing that, I would take the time to just say we share a common factor. And so what we get is really 4 root 3, and honestly, that's exactly what I'm looking for here. It's just 4 root 3. So taking a look at letter B, 2 cosine 30, really what I'm looking for then is, can you tell me the cosine at 30 degrees? Well, looking at your unit circle at this angle here, 30 degrees, our cosine value is root 3 over 2. So we get 2 times root 3 over 2. Again, I can put my 2 over 1, but these cancel this time, and what I get is just its value, root 3. So just evaluating. Now this last one here, 1/2 times the tangent at pi. Well, the thing is, we have to go find what is the tangent at pi. So pi is given in radians. Keep in mind that pi is always the same as 180 degrees. And so 2 pi would be the same thing as 360 degrees here. Pi halves is up here, and then 3 90-degree rotations would be 3 pi halves. But essentially, the tangent at pi means that we're actually going to have to go take the sine value at pi divided by the cosine value at pi, and we can find both of those here. And so our tangent value at pi would be 0 over -1. I'm actually going to write that here. But essentially what we get is 0. And anything times 0 is going to be just 0. So you need to know your unit circle. You need to know how it relates to the cosine and sine and tangent values. But then be able to use your unit circle to evaluate expressions such as these. Cheers.